it will actually generate a pop-up. Or you have to call the show function explicitly. Huh? It's coming directly. That's okay. Is there a way to swing it down because it's not coming anywhere? Yeah. Swing it down. Okay, so let's see. So this is what it means. Now let me generate the data. Let me import numpy as np. Right. Let's generate the data and do the plotting here. np dot namespace 0 to 10 100 data. Right. That is what it is generating x. So plt dot plot x. Right. You can see the data that is generated here. Only one axis of data. Right. This is index number. This is the value. Right. The value here we are doing between 0 to 10. We are generating 100 numbers. That's precisely it is doing. Let's create a little pandas data frame. Import panda where's pd. df is equal to pd dot data frame Hey Anubhav, is it not audible?
It's audible to me.
Anubhav, let me drop you a message. Yeah. Right. So this is my data frame, which has basically only one column. Right. I want to create another data frame. x2. x2 means x square. Okay. Here df dot x into df dot x. This is x square. Okay. df x cube df dot x2 right. So if you see the df now, this is how the data is. Understood, right? Right. Now you want to plot the relationship between x square, x cube, and all that. Okay, so data frame directly can do that. Remember, earlier I saw from plotting I'm going to pass the data. Now from data frame df dot plot right. So you can see this is x, this is x square, this is x cube. You can see the relationship. See the difference between the x cube brings to the table, isn't it? Really exponential. Huh? Color automatically it figures out. Yeah. That's it. Color it will figure out. This is what I'm generating this. I mean, you can use any other way to generate the information. This is x, this is x square, x cube. Make sense? Okay, so you can get it from data frame also. Now remember we want to sometime many times plot the histogram information count, right? How many times a particular data is appearing and all that. So we can earlier times what we did is pd dot read CSV.
This opposite side also like that. If x.
This is the value of x. This is the value of y.
Like that, we plot this side x. No, y side, the opposite y side. You can do this.
You have to change the dimension.
No. Two side plotting. I want to do this. You can do this.
Two side plotting means?
Like that, y side we are doing this plotting of data. This graph we will do. But that side also, this side also.
This side also in the sense?
Plotting. We can do this.
That empty space?
Yes. No. Like this is the y-axis, okay? This is x-axis. This y-axis we can plot.
You can probably, but generally y-axis is always here, right? You can actually. So what you can do is, there must be some parameter. This is not a common requirement. Not right. So you can actually do this way. You can plot horizontal graphs. Okay, I'll show something. You can plot horizontal graphs. So here in community, you'll find all the study regarding plotting. Okay, so here this was our basic plotting that we are doing now, right? This is the x square, x cube, and x and x square, right? So of course, you get a control. You can tell what you want. You can see here, right? plt.xticks, plt.yticks, plt.legend, x level, y level, all you can configure. X is this part actually. These are not sticks. This is the x ticks, this is your y ticks. Okay, this is your title. Okay, this is x label, this is y label.
And what is legend?
But anytime recurrent is coming like that. This Charters.js, we can plot the two sides also, x two side.
Actually, you can do a lot of customization. Okay, but might be, those are not common. So you won't do that because you don't want to confuse anything unnecessarily. But you should be able to do each and everything. It's highly configurable, highly flexible. Right. See here it is doing a df plot. You are passing a title, you are passing a legend, you are passing an x ticks, y ticks. So let's do that. So if we title, polynomial graph, polygraph. Right, see? Now the title is created here, understood, right? Then you give x tick. X ticks. X ticks are, what are the values? 0, 20, 40, 60, 80, 100. Okay, so 3 plus 3, 6. 25, 50, 75, 100. Did you notice what happened? See, your text changes, right? That's the whole idea. You can define your own scale, definitely.
This is creating Indian. This graph is creating the.
Oh, it's actually creating an. If you want, you can save it. See if we need something like that. If you come actually. Plot. You can save it. For example, the line above, right? plt dot save field. Some problem with this guy directly. Or you can call this function safely. All right. The previous guy gets saved here. You can see here this a.jpg getting created. Okay, so this is the second part. Now let's see further. You want to see the distribution of the data. You want to plot the distribution of the data. So, like, you know,
This PLT is used very PLT.
PLT is the image that we created above, right? Plot. You see this.
Nothing is coming in the graph.
It's actually not becoming here, but it should be
Or
here.
maybe something like that.
That's it.
So for example, if I have any data frame, I can give the df.plot. But if I have a numpy array, I cannot get x. I cannot get x.plot.
You have to create data frame out of it.
Okay. There I can just take plt.plot and there.
It will not actually.
If I give the plt.plot inside it, I give a data frame.
PLT.plot, even that will not work. You have to give column names and all that. So there is Titanic data. I want to show the distribution here actually. Basically, I want to show histograms around it. Here's the data. Go to raw. Okay, so this is the age column. Basically, first we want to get rid of all the null data here. Not null. Right, it basically will, if I do, okay, now you do this count age dot count values. Where he counts. Right, you can see here that for each age I'm finding some distribution here. Got it, right? Right, for each data I'm finding some information here. I want to plot. Yeah. What you do is plt dot hist. Okay. Data. Data is your values actually. Okay. So what is my information? Age hist. Age hist. Dot values. X. Right. So you'll see here, this is the distribution of people. Understood, right? You see the histogram here. You can see that a lot of people are between the age of 20 and or 25 and 35 mostly. Of course, a lot of infants are also here, but this is the distribution of people. Yeah. Right. So basically, you're plotting a histogram here. You see the parameter one is data. Data is the values, and this is the index. Make sense? Now, what you want to do? This is a basically we want to find the relationship between age and survived. Basically, no age and I'm trying to think two continuous values actually. So nothing is coming to my mind. I'll use another data set to explain that. PD dot. Right. So this is your employee data, which you have seen earlier also. Right. Now, see if I see the data, if I plot the data, you can see we have something like satisfaction level, and you have something like average monthly hours. Okay, we want to find the relationship between satisfaction level and average monthly hours. Relationship between satisfaction level your average monthly hours. ELT dot scatter, right? Scatter, and basically you have to give data like this. PMP data, what is the column name? Satisfaction level, comma, EMP data dot average monthly hours. Okay. And and basically third information that you want is left or not left. Okay. So color is equal to EMP data dot left, and can you see the pattern?
What is the left? Dot left?
Dot left is your, and I have to do this legend thing. ELT dot legend. Wow, something really amazing. I actually didn't just try to see this data earlier like this. You'll know, I'll explain what is happening now. Wait. One thing, you know, is very unique to data science. This is a very simple data. I think I have used this data n times. You know, I just tried something different and it shows me completely different picture. Okay, what is happening here? I actually never tried to plot this S earlier. Sorry, C. C is the color of it. Okay, what is a column? Employee data dot left. It is column which is the employee left dot between leave color column, 0 or 1. Right. So if 0 means one color, 1 means so here you can see the purple ones. Purple one print did not leave. Got it, right? And 0 is, I mean, yellow ones left. So you can really see this is the pattern of data who actually left. Right? What is this pattern? This pattern means people are who are putting lot of efforts and they are less satisfied. Understood, right? This is the satisfaction level. How do you know that? ELT dot X label satisfaction. ELT dot Y label. Average hours. AEG. Right? You can see this is the trend of people who are living. This is the trend of people who are living. This is the trend of people who are living, isn't it? Right?
Left this.
One amazing stuff. People who work a lot, people who are highly satisfied also, they also can live. So
If you remove this one left one, PMP data.
then color won't come actually. It will be all same color blue.
Is there any other way we can like give color names like I want red and blue?
Ah, you can do that actually. Here in place of this, right? You actually here there is another option, CMap. 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 Here you can give Virdis. I think this is Virdis only. No, Virdis spelling is wrong. CMap options is Google. Huh? I forget. So there you will see Matplotlib color map options. Viridis, not Viridis. Okay, this is Viridis only by default. So you can give it Inferno. 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 Right? So play around with it. That's the whole idea. Okay. Okay, let's see more data. Let's understand pie charts now. You understood why scatter graph is for continuous versus continuous data relation. Your histogram is for categorical data also you can use, and you can use it for continuous data also. Understood, right? Histograms. Histograms, how many times a particular age we plotted histogram, that is also fine. Also, you can, if it is categorical data, you can use histograms. Now, we want to do this plotting now. ELT dot box plot. Box plot and give a column name here. Basically, EMP data of oh, it is not there. Oh, it's a Titanic data is, sorry. Like you can see here, this is the lowest stage, this is the highest stage. This is the mean of it, this is 75% of it, this is 50% of it. No, 75% of it, this is 50% of it. Understood, right? Box plot, it will show the plotting for you. If you want to plot different features together, you can give it comma separated and all that. Make sense? Now comes pie plot. Pie chart. Pie chart is very useful when you have to show distribution of categorical data. Like employee data we had, right? This is employee data. Employee data had different departments. Like if you do EM data dot, actually the data, if you remember, the data has wrong column name. But you can see the column name is wrong here, sales. It should be department. These are real situations that happens that way, right? So rename. Okay, give it column. Sales. You have to give increase equal to true. Right, so the column name is altered now.
In place, that place, in place.
Yeah, in place means the data will be changed there itself. Okay, it will not return a new data. This is department. Okay, value counts. If you do, it will tell you distribution of each department versus count. Understood, right? This is something you want to plot in pie charts. Employee department distribution. Lockdown. And data. My index will be not convert string to float. You just need to see this pie chart. Okay. X is equal to data and labels is equal to x. I actually wrote it wrong, right? This should be x. See the information now. Understood, right? Okay, x is the data values. For each thing, what are the values? And this is the index information labels. Okay, this is the index information.
Just the determinant count.
Huh?
Determinant count, right?
Department dot value dot counts. Value counts will give you frequency distribution. And from, if it is categorical data, we are going to plot pie charts.
And then something like what are parameters we can send.
Yeah. I want to help you installing Tableau also. Tableau desktop version is free. We used to not do that earlier. Now, you can parallelly actually install it. See, visualization, actually, you just need to know one thing well. Apart from that, other thing, just have that working knowledge. I mean, you should be just able to open it or, play around with it. Tableau is free for one person user. Companies, of course, if you are paying, but it has a lot of good visualization. Okay, so you can create a Tableau account, and tomorrow just make sure this installation is done so that I can show a few things in Tableau. This is how you do. Okay, because you need to know it. I mean, you cannot just say to the employer that you have not done anything. There's a lot of people use Tableau, so just give it a shot. Understood, right? It is pie chart visualization. So it will basically tell you that a lot of people are in sales, a lot of people are in technical. HR management is a very smaller team compared to all those things. And you get a brief idea around that. So box plotting, all those things we have done it. Yeah, so now you should be actually taking up a data, doing some data analysis, some visualization on the data, and you should make some story around it. Story in the sense, what is the distribution of the data? Right, if you see
Is there any assignment like where you can practice in my
Yeah, you can show percentage also in the data. Auto percent is equal to true here. Auto percent. I think you write. Percentage, something like this.
what is this one?
Percentage one. It actually will print the 1.1f. 1f. Percentage 1f11. So if you do that, you can see here percentage getting printed here, right? Make sense?
Can you increase this size of this chart? Is there any?
Everything is here. Okay, everything. So here we can plot. So this we can use this as a references here. So here I think there is something known as size. It's not size. It is known as. You can do this also. Something is coming out, right? To explain something, right? You can actually use this is explode, right? Explode.
But I can understand the values that you were passing.
So it is actually 1, 2, 3, 4, 1, 1, 2. Okay, this is the degree by which it is coming out. 0.1. Must be of length of x. What is the length of x? EMP department values 3, 4, 5, 6, 10. Four, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. Just if you do this, you will see one of them is going 1.1% outside. Can you see this? Whichever you want to do, you have to write corresponding value, how much explode it has to happen. Got it, right? If you want to make it little more far, you make it 0.2. Got it, right?
How are you getting the individual node for?
It actually happens from this value, where whatever this value is. Right? If you do indexes, understood, right? So the sales is 1. So it is how much? 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. R&D. R&D outside. Okay, see, the thing is, of course, you have to remember. I mean, it's not possible for anybody to remember all that stuff. But no, it just, what is the syntax? What is how it works? Whenever you read it, you have, the differences are there to refer that and come back and. This is exploring.
This is the image or this is direct data?
This image. If you want, you can save it. Right. And if you want, you can do this also. But these are images also. If you want, you can save it. Like this image you can actually. ELT pi, then ELT dot save it. Okay, so you have ab dot jpg. Okay, not showing. Can we explore dynamically? Let's say percentage. Yeah, you can do that. Just that you have to programmatically find the right things. We can explore dynamically. Let's say percentage. Yeah, I mean that parameter actually. How much outside you want to do? You can do that. You can all the things programmable.
So instead of JPEG, we can save it in different format also, like in PDF or.
So this is how you have to save it. Think. Okay. Then. Okay. Okay, so you can see it's getting saved here. No, it's not getting saved. Okay. Okay, so now let's do a small exercise if you are carrying your laptop. Okay, in the same employee data. Okay, try to plot histogram of satisfaction. Okay, 0 to 0 0.1, 0 0.1 to 0 0.2. Okay, what satisfaction is? Or say, any way you want to plot histogram of satisfaction. What is the trend of satisfaction?
The satisfaction level, you have to draw a Instagram for that.
XP. XP.
Vinay.
We don't have this X taken histogram. We're not able to change the X in this X parameter is not present here for this.
So what you have to do is use this histogram. Basically, these are different data frame columns. Understood, right? So this is column A, this is column B, and if you do histogram column names, it will basically tell you the distribution. Right.
For example, if in my graph if I have 0.2, 0.4, 0.6, I want to make it like.
Oh, that's how you're
0.5
getting.
and
Is that how it will happen? Let me also see. Okay. So do this plt.hist. Right. Then emp data dot satisfaction level. Right. So this is the distribution.
Now if I want to change the
Yeah, this is coming up. But you wrote something to divide into the x into 0.1 something you wrote, right? The 0 to 0.
That's what is happening, right?
Yeah.
Here, if you want that way, you configure one more parameters. That's what will happen. 0 to 1, 1 to 2, 2 to 3.
Yeah.
Got it, right? ELT dot sticks. Yeah.
What is that bin basically?
Bin when you give 10, right? Automatically it is bucketizing it. What I said, right? 0 to 1 range and all that. It is automatically doing if you're giving bins here. Bucket size. Got it, right? You know, make it further deep, then you can do that. But you can see the distribution here, right? Right, so this is one way. Okay, fine. Now, we want to see if there is some outlier with respect to this. Okay, we want to see if there is some outlier. This is employee data, right? It's a new lot of data. Yeah, I'll come to that outlier. Okay, so let's see this. So we did some visualization here, right? You can refer these notes and try some all the cases, right? You can see here histogram for different columns, which will tell you different column distribution. Each column means different color. Make sense? Right? You will understand what is the each feature distribution for all the data by getting that information. Okay. Now let's proceed further from this. Last time we discussed about normal distribution and all that, right? What is normal distribution? What properties around it? Given a data, how do you find? I mean, if you can plot it, you can find it. What type of distribution? Right?
Earphone है क्या?
Okay, so that's full drill around distribution of data. So plotting the data is kind of, I mean, plotting is something that takes time actually, and you do that whenever you're dealing with data. Okay, so do this as an assignment. So what you have is, you will find a lot of data here in my GitHub repository. At least few of them will find you. Okay, so you have this HR data, sentiment data, adult data, churn data. This is your credit risk data and rental data, text data, right? You can try playing around with it, plotting information, doing some basic data analysis on all of it. Okay, so let's see where my W is reached. It's just an introduction, the basic stuff I want to show. Okay, the idea is, even if you don't know this thing, even if you don't do it, I mean, you can try some things to do. It's really easy. It's very easy actually. A lot of good references are there. I won't show them all of them, but basically, I mean, the answer should, if there is a tick mark to be done, the answer should be always yes, W done. Right? It's kind of important.
Graph is look and feel good. Graphs are look and feel good.
That visualization is good. Nice visualization. Okay. Then another option that you have for visualization is Plotly. And Plotly is good actually. Where it install it takes 10 days. Plotly also, but here also Plotly also you need to create an account. Okay. So and it needs internet to actually do the visualization for Plotly. Matplotlib is free. Nothing else is free. Oh, jeez. Okay. So for Plotly, what you have to do is Plotly. Okay, first you have to create an account here. I'll show you how to use it. First is I think I'm logged in here. Because when you're looking for jobs, right, they'll write all the visualization too. But it's not definitely not expected that everybody will know everything, but this is what. I don't know what happened. You guys created the account?
Yeah.
Someone's behaving in this. Plotly. It is used in a lot of companies. I think you mentioned your See, I mean, there are a lot of tools. Like there's another tool, Weka. Might have heard about it. Vector. Okay, this is a data science tool. See, the thing is, you're when you're talking to somebody, I mean, these things get important, right? From a job perspective, from a just to mingle with more data people who are really working, you need to have certain keywords around it. So these is where the all things is this is superficial things get important here, right? So just that though the reality is that this doesn't matter much, but it matters actually. That is how the conversation strikes. So you don't want to say no there. That's the reason I just touch upon all these topics. So wake up, have a note of it. Just it's in the installation. The system has gone heavy. Right. So here to use it, you have to a lot of it are good actually. As the reason it's paid. Okay, because companies would want very good interfacing, right? Few things. Is Plotly on? Yeah, it's compatible with Python also. Okay, so it's showing login, not import. Okay, you need some keywords and all that here. Some sorry, not keywords, some keys and see access code. So if you click here, I think in the name, the settings. You can see the price here, right? $420 billed annually and all that. This is again public corporate, so we are anyway here. So here you have API keys. Got it, right? So as you're asking, Nilanjan, so you have for Python or this thing, you have the same stuff. Okay, and you can do stream token, live data also you can use actually. Got it, right? Okay, so
UI based, we do not have to code anything.
no, you have to code. I'll show you. Okay, you have to connect your Python code to this. Okay, like like this is our Python code, right? Okay, you have to do install Plotly first. Okay, then you have to set credentials like this: username and API. Username is whatever I have. Okay, and an API key. Like this is my username and this is my API key. Right, this is my API key. Understood, right? Okay, so here install Plotly. So the Plotly package is installed. You have some APIs and all that. So you have to configure them all. Then you have to do the visualization. So your visualization will become this. Don't close the screen, else you have to regenerate. You can import the data directly and do the visualization here. Right.
Directly I can upload any CSV file.
Yeah.
And do that.
And this is it. So it's downloading this way. Right. You always write here actually colon pip install Plotly. So yeah, colon is yeah, sorry. Yeah, so here it will actually do the installation. Okay, all the installation and all right, you can directly do it from the screen. Don't have to close the Jupyter Notebook window and do it in the back end. Once this is done, tomorrow I think we can start machine learning and all that.
So,
Yeah, I think you guys can skip. Yeah, this is a data science is a superset. You know, whatever we have done is data analysis, which is like basics, right? Whatever we have done is getting data ready. Next phase is actually doing the prediction, understand the maths behind it. Okay, so we'll learn all the statistics, all the maths for that. Okay, calculus, probability, all those things we'll learn. Let's stop. Let's
The username and the
API key, right? For a sample code, you'll see they're using. Yeah, you got that right. It's a little stuck actually here. Okay, so just search for you generated this IDs. Then just search for Plotly, and you'll see very easy code actually. It's very much based on your matplotlib. Okay, then do that. I wanted to show something on Tableau if it does not get stuck. There are 2-3 things now. Yeah, install the Tableau and it's just stuck actually. Hello, is it audible? I think it's a little stuck.
What's the advantage of having totally over this backward?
Good looking. Good looking. Good visualization.
Do we have something similar to NumPy also?
But not this. I mean, you have tensors in TensorFlow. That's different for deep learning. Like NumPy is not distributed. There is a distributed library. It's gone. Sure.
This machine learning center that we're having in weekly, weekly functions of August, mid of August.
Middle of August, I can finish.
After that, will we have any batches that will be starting by that time?
Yeah, because the current deep learning batch will finish by then. So
There it will take like August, mid, September.
We'll go till September, mid-September. No, it's 2 months. Yeah, I think it's like what's actually the VM is also running, and some there I'm running some deep learning related application from previous session. It's pretty stuck if I do all of them. Okay. I think I have to reboot.
I'm not able to option this happening.
You executed this. You executed. You saw my bar graph, right? It didn't happen. Right? So then what you do is you're connected to internet.
This plot will
Now it will happen. Star is there, right? Guys, is it audible?
Yes, Avantik, it is audible to me.
In middle, was it disconnected?
No, the screen was black.
Acha, acha, it was stuck actually because
but you were very much connected. Yes.
okay. Okay, so I think I might have to reboot. So you guys, create a Plotly account, install Tableau. Got it, right? Okay. Let me see. I'm stuck now. Some deep learning application.
Yes.
Okay, you do this. I just wanted to show Plotly. Just use oh, come on.
So Avantik, I have some knowledge on Tableau.
Oh, nice.
So, yeah.
Yeah. So that's it. I mean, do the installation tomorrow. The first thing that will show something on Tableau. Then we'll start with machine learning from tomorrow. Got it? Okay. It will include. We'll start with the linear regression tomorrow. We'll understand whatever maths is required for that. And Plotly is one more option. So it's nothing varies much. You just have better. And one thing that I introduced is WEKA, WEKE, right? So the idea is, that's a data science flow, and somehow companies started using it. Good to experiment with it. Have the jargons ready. Right? That becomes really important. That's all for today. Okay. Tomorrow, just if you read a little bit about what is linear regression and all that. Okay, we'll start with that. Is it clear, Nilanjana, Shobik, Sonal, Abhinav, Anubhav? Sorry.
Yes.
What time you have class? Today you started with
Yeah, 3:30. Tomorrow also we'll start at 3:30. Monday we'll be starting with an A-base. Probability theorems. After that, we'll be getting to new base. Yeah. Text analysis part will be. Right. So go through these stuffs. Okay. I will be sending all of you the all previous recordings actually. Just count. Everybody got my mail today of link.
Yes.
Okay. So this I think I have uploaded all the videos. Few of the folks I have sent, but I think I entered to all. So I'll do that now. Okay, I'm ending the meeting because my system is completely stuck. So I don't think. Yeah. You just fine, right? Fine. Okay, I'm ending the meeting, guys. Huh?
Ready? Yes.
So I have to check there if I can come late on 3 days in the week.
Oh. Achha.
Monday you have class?
Within those, I think I just sent the video. After the, I think let me reboot. After that, I'll send the videos and go through them. Okay. Bye. Bye.